Welcome to Pavitra Laptop Care. Before starting, first we need to understand how a laptop will work. How a laptop will work. Okay? How is the question mark. See, first thing is you put the charger to laptop, right? Or battery. So it means laptop will work through charger or battery. What is charger then and what is the battery? See, the main concept you need to understand first. Then you can easily do the repair work. Here charger and battery will give voltage. Only voltage. Keep it in your mind, it will give only voltage, not current. Current it stores, the capability of the current it stores. It's 65 watt or 19 watt, 190 watt or 90 watt or so and so, 130 watt, right? But the thing is, main source will give you pure DC volts, not current. Okay, not current. You know why not current? Because before that you must know the difference between voltage and current. The current is called flow of electrons. Flow of electrons. Okay, but the voltage is a force to move. Flow of current, flow of electrons. Okay, this is the major difference between these two. If you want current, you want some force. If zero force, zero current. If you have 10 volts, then some millivolts or micro amps current. Right. If voltage is there, this will be there. If voltage is not there, current won't be there. Through this concept, using electronic components, your motherboard will work. Okay, this is the main concept of the laptop. Okay, this is the first question. First thing you must know. And next is, see, I am coming very slowly because some people won't understand. That's why very slowly I am talking. Now you got the point is voltage and current. See, the main force, if you in case of AC voltage, just you switch the on button, then current flow and light or bulb will glow. In AC I am talking about, at house, that may be, what is that, 120 volts or 230 volts, whatever it may be, 50 hertz or 60 hertz, 250 volts, anything. If you press the button, light will glow. Right, this is direct one. If you apply a force, AC voltage, then current you will get it in bulb. This is the concept in bulb situation. Directly load, you will get the bulb. But in DC case, you need multiple sections. There is this. You need multiple sections. Right. See, in AC 230 volts you apply directly, you will get the output. But in case of laptop, 19.5 or 20, whatever it may be, or 15 or 12, if you apply the DC, the load is not only one, it has multiple, right? The concept you must understand. If multiple loads are there, then different voltage is required. For example, it's a 3.3 volts for lights, LEDs. For processor, so 1 volts, 1.05, 1.5, 1.35. multiple voltages required to processor. Correct. For that reason, what we are going to do is the force for multiple sections we need to apply. It's not directly one shot, right? If you turn it on, then output you will get. But here multiple sections are there. To get these multiple sections, multiple forces is required. Nothing but voltage. That's the reason in laptop you will get 3.3, 19, 5 volts, 1 volts, 0.6 volts, so and so. So it depends on circuits. Depends on circuits. Okay, the basic point you got, right? So now we'll come to the point. In laptop motherboard, one thing you understood, multiple loads are there. Loads, right? So for these multiple loads, we are applying voltage through adapter and battery, right? What we are getting in this voltages in adapter 19.5 volts or 20 volts, and here battery is 14.5 volts or 12 volts something. Why these two are different? I will tell you in future classes. You can use 19 volts, right, in battery also, but here much difference are there. Why we are using this? So these things I will tell you in later. Okay, now for adapter it's a 19.5 volts, for battery 14.5 volts. Okay, this is force, but it's like a switch, right? We can't switch it on and directly a load will work. But using this, we have to activate multiple loads, right? To activate these multiple loads in electronic components, using electronic components, we can convert as per the load, convert the voltage as per the load. If we convert the voltage, then current is available that much. For example, here to charge a battery 3 amps is required. Just example I am giving. For 3 amps, what will be the voltage that the circuit will carry? Understood? The circuit will carry. Now, one thing you understood now, there will be multiple loads in laptop. You are using 19.5 or 20 or 15 or 12 volts adapter or battery 14 or something. So using this, what you are going to do, you are using electronic components. Using that, you are getting the load. It means if you on it, this particular load will give output. This particular load will give output. For example, this is for processor, this is for LED. LED works only 3.3 volts or 5 volts or 12 volts, whatever it may be. But processor, multiple volts, 1 volts, 1.05 volts, or maybe 19 volts. That sections. So now you got my point, right? So using these voltages, we are giving current to the particular load. See, main thing is current will work in a load. If there is a voltage, only for voltage, the output won't work. Please keep it in your mind. Only using voltage, your output won't work. The main intention to give the voltage is to flow of current, to flow of electrons in a circuit. In a circuit, see, one more word we got, circuit. Okay, the current, one more important thing I am going to tell you. Current always works in closed circuits. Okay, the circuit is closed, then only the current will flow. In case of voltage, will work in open or closed. Any condition you will get. For example, best example is if you take adapter, there will be the positive and negative terminal, right? Here you will get 19 volts or 20 volts, whatever it may be. It's open circuit, it's not short. When a loop will create through electronic device, then it's a complete circuit. Here flow of electrons will happen. Flow of electrons. Electrons is a negative charge. Right, once the flow of electrons happens, then you will get the laptop on. Right, if you consider laptop is a one circuit, then you will get it on. If any problem occurs in the circuits, it may be short or it may be open, then it won't turn on, right? But you will get voltage. You will get voltage. It means voltage will work in open circuit, closed circuit or short circuit, whatever it may be. In short, actually it will be zero, but generally I am telling, actually it will work. The current won't work. Now you understood, current will work only in closed circuit. Okay, current will work only in closed circuit. It won't work in open. And it will work in short also, but it will be high. So if you want a load, then this short is not required. So we have to make it closed circuit to get the appropriate load. Okay, this one will get blast the components. Now you understood, right? The voltage will work in open or closed or short. Actually short, it will be 0 volts, but the loop will be, here is a 12, here is a 0. It means it's completely 0 means it's a short. In practically you will get 0 volts. So now you understood what is the current and voltage. One more term is watt. If you multiply this current and voltage, you will get watt. It means the multiplication of current and voltage in a circuit, in a closed circuit. This is very, very important. In a closed circuit, here to here, in a closed circuit, then it's a watt. For example, 90 watt, 65 watt, 45 watt, and so on. Got my point, right? The circuit, closed circuit, what will be the current and what will be the voltage to get the load? That we will calculate and we will tell it as a load, I mean watt. Okay, this is also one more important point. Now you got my point, right? One is voltage, current and watt. These terms you come to know. Now the main thing is, next is circuits. What are the what is that importance of voltage and current and wattage in a circuit? This will depends on load, the output load. For example, laptop, if you consider is a laptop is a load, then the voltage current, depending on that voltage current, your laptop will gets on. Okay, now the fact is, in case of open circuit, only you will get voltage. Okay, the potential difference you will get, nothing but voltage. In closed circuit, you will get voltage plus current plus watt. This concept please don't forget, it's very, very important thing. Okay, how a circuit will produce, how we can create a circuit, it depends on what you are getting the load output. Okay, about the circuits we'll tell now, just a minute. See, the circuits, I told you the circuits will be three parts. One is open, second one is closed, and third one is short. Okay, open means a circuit through an electronic devices, it won't connect to the ground. It's called open circuit. Closed means in an electronic circuit a source will be completed. Short, before going or before going to the load, for example here is a load, the voltage or current will be get short here. Track once it gets short, then the particular what we are aiming, the current should go to load, it won't go load, directly it will short here. So before load it gets to 0 or minus, then it's called short. These are the major difference between open, close and short. Now the circuit, how it will create. The circuit will create by electronic components. Electronic components. What are those? In electronic components there are two types. One is active components and passive components. See, what are the necessary of these components? To control voltage and current. Here also to control voltage and current or limits. Control or limits. Okay, in a circuit. To control voltage current in a circuit, we are using, according to the load, we are using active or passive components or both. Now you understood my point, right? Now in a circuit, what are the components? First I will come by passive components. Passive means we can avoid it, we can limit it, but we can't control the voltage. For example, if I give the 12 volts input and I will control it by 12 volts or 5 volts or 12 or 1 or some other things, we can control it, but passive components won't control. It just passes through that particular component and it limits. In next class I will explain you how active or passive components limits the source. See, for example, here is a 19.5 or 20 volts. How it will control this resistor or capacitor or inductor or diodes or transistors or MOSFETs. All, each and everything, theoretically as well as practically. What will be the result of these things? I will explain in next class. Okay, these are very important things. I am going very slowly because you can easily understand this. Step by step I will go by slow, and after that I will increase my speed. Okay, so that's it. Please have a note of this. These are very basic one and very important one. By knowing this only you can understand better in future classes. Okay, thank you very much. Now I am going to explain you, in case a source of voltage enters in any basic passive components, what will be the result in a circuit. Okay, first we need to understand a component level voltage, how it will pass or how it shows. Okay, now see, this is resistor, 0 ohms resistor I have taken, and here 19.5 volts supply I have taken. Here is the positive and here is the negative. See, here one thing you always keep it in your mind, the voltage across the circuit, in case it passes across the circuit in a complete loop, then only current will pass. I'll repeat, once complete circuit positive goes to the here one end, source end, and destination end goes to negative. How many components, that's the secondary thing, but it should be connected. Then only we'll call it as a complete circuit, and the appropriate current in microamps, not in milli, not in amps. Okay, it will be in microamps. In that current it will pass. In case of open circuit, the one path is connected to supply, then voltage only we will get across the component. This is the first point you need to keep it in your mind. Okay, now this is supply. What is that? 19.5 volts. I will connect to a resistor. Okay, I will connect to a resistor. Then what will be the result? See, one side. I have connected one side only, but here I have not connected. See, one more important point I am going to tell you. If it is the open circuit, only one point is connected to the positive supply and negative supply is open. In that case, the component, whatever it may be resistor, or it may be capacitor, or it may be inductor. The other side also approximate voltage you will get. After that component works, the voltage you will get here. It means it's a destination part also you will get the voltage. Here, what is the special? You can ask, right? The thing is, in case destination is connected to the negative, it will become 100% zero. See, for example, this is the resistor, here it's open, here also we will get the voltage. What voltage? Here what the supply is there, that voltage we will get. In case it is connected to the negative point, then there will be no voltage. Always zero voltage you will get. This is very important point. Once the destination is connected to the negative path, so always you will get 0 volts. Please keep it in your mind. Okay. Now see, the 19.5 volts we have connected. Now we will check in the multimeter, where we have to check one path is here positive one and second one is negative one, but make sure this is not connected. Okay. Now what will be the voltage? This point. Okay, here across this resistor, what will be the voltage? See, 0. Across this we got, it's a 0. Oh, 0 volts. How come? I just now I told it will be 19.5 volts, but here it's a 0 volts. Once again I will check. Once again, yeah, it's a 0. Okay, I do one thing. I will increase the resistance. See, what will be the result? I'll increase to 1 ohms. Then what will be the result? Now here is the 1 volts. Okay. Now I will check what will be the result. See. Oh, something, it's a pico volts. Okay, anyway, I do one thing. I'll make it 1K. 1K. Then voltage across this resistor. Oh, there is no voltage across this resistor. Okay, I do one thing. I will check one point in negative and one point here positive side, before resistor and after resistor. Then what will be the result? See, this is the positive one. I'll connect here only, and the negative one I will connect to the negative path. So now I will check across this part what will be the voltage. Oh, 19.5. Okay, this is the open circuit. I told here voltage will be there, but how you want to check? One thing is it should be connected to the negative path, and other one is where you want, there you have to connect the multimeter, positive point. Okay, here you will get the voltage, right? Okay, now what I'm going to do is I will connect it here. So what will be the result? See, here is 19.5 and here what will be the voltage? Here 19.5 volts. Okay, here also actually this is open circuit, but when you testing with the negative part and this part, then you will get the voltage, but it's a open circuit. Now I will connect this to negative and then I will check the multimeter. what we will get. Okay, now I'll stop it. So now what I'm going to do is drag this and here one connection. Now this one is connected to the ground. Now I will check the positive part here and negative part is here. What happened here? See, one short happened, right? So the multimeter, if you connect this point and this point, it will be continuation. So that's the reason here always if it is connected to the ground, it will be 0. Voltage will be 0. So now I'll check 0, obviously, because it's connected here. So whenever the destination part is connected to the ground, 100% there will be no voltage. Before the component, voltage will be appear, and after the component, voltage does not appear. Okay, now it's voltage across a single resistor over. Now voltage across double resistor, what will happen? Now what I'm going to do is I will disconnect the multimeter and I will add one more resistor. See, one more resistor I will add. Now I will connect these two. Here destination part I will connect. Okay, now it's a negative, it's a R2, R1 is a positive one. See, in this circuit, here this point what will be there and this point what will be there. Generally, of course, what are the components, even resistor, capacitor or inductor, whatever it may be, if it is connected to the negative, it will be ground. Here the voltage is 0, and what about here? That we will check. Now this one I will make 1K. So voltage across this and this, what is the result? See, first I will check this part. This is a before voltage supply, right? It means main supply voltage only will get it here. So now I will check. See, this part voltage has 19.5. Now both are equal resistance. In this condition, what will be the voltage at this part? So now what I am going to do is multimeter, I will check this point. So I am going to connect this one to this point. So now here voltage across this part, what will be the voltage? See, 9.75. It means the resistor of 1 and 2, if it is equal, then here midpoint you will get exactly half of the voltage. Half of the voltage. So voltage drop across here it's 9.75 and here completely 0. Here what was the voltage? 19.5 volts. Here it will drop to 9.75. Across these two resistor 9.75. Okay. Now what I'm going to do is, now both are equal, right? R1 and R2 both are equal. Now what I'm going to do is I will increase it to R2, R1 I will increase to 2K. Then what will be the result? See, now 2K happened. What will be the voltage across this point? See, 6.5 volts. So it means in case R1 is greater than R2, R1 is greater than R2, the voltage across this point is less. This point is less when R1 is greater than R2. Please note down this R1. If R1 is greater than R2, the voltage will be less across this part. Okay, point. Now what I am going to do is here 1K and R2 will be 2K. I'll make 1K and here 2K. So now what happened? Let us check. Voltage increased. It's a 13 volts. It means in case of R2, the destination part resistor is more than R1, then across this voltage, it means voltage divider part. Okay, this part the voltage will be more in case of more resistance at R2 destination part. Now you got my point, right? So now what we have checked, R1 and R2 both are equal, then here exactly half voltage you will get of the source. Now R1 is greater than R2, then here the voltage is less. Okay. Now R2 is greater than R1, then here the voltage is more. Okay, you got my point? Okay, I do one thing. I will add one more resistance across 3 resistor. What will be the result? Okay, here I'll stop this. I'll copy and I'll add it here. So now one more resistor came. See, this one I will delete. These two connected, and here we connected to ground. So now voltage across this part and this part, what will be there? Now I'll make all three 1K. Okay, this also 1K. See, I'll show you voltage across here and here. What will happen? Now voltage across here 13 volts, because just to think about it, here R2 plus R3 both are added here. Okay, in series, if there is a voltage in if there is a resistors, multiple resistors are in series, then it will add. If you want voltage at this point, then these resistance will be add. It means previously I told you the R2, if we consider adding this one as a R2, then R2 is greater than R1. In that case, voltage will be more. Correct. So now this point, if we checking this point, here R1 plus R2 will be added and consider as a R1, and this one is R2. Then what will happen? Here is the voltage will be more, then here is the less. That time this part will be less. Okay. Now I am going to connect this one to this part. See this point. So now what will be the voltage? Here R1 is greater than R2, right? So now the result is less voltage you will get. Okay, now you got my point. Voltage across 3 resistors. Sometimes in schematics, why I'm going to tell these things are, see, in schematics 3 resistance dividends in thermal section, especially in thermal section, 3 divided resistors are given in a circuit. Okay, in that case, if they are taken this point, what will be the result, and this point, what will be the result, that you need to carefully check. In case they have taken this as a voltage divider, then you need to add these two and then calculate as a voltage divider formula or Ohm's law. Okay, now you got my point. Any series condition resistors, in case of R1 is greater than R2, I'm repeating because you should remember it. Okay, see, in case of R1 is greater than R2, then here this part voltage divider is less. In case of R2 is greater than R1, then this part will be more. In case of both are equal, then what? Equal resistance you will get. See, now I have taken a schematic. In a schematic, first thing you keep it in your mind, the thing is the voltage across components. Okay, just now I explained you voltage across 2 resistors, what it will be there. First resistor, first part will be source, and second resistor or last resistor's destination should be ground. Then only we consider it as a voltage divider formula. Okay, so now you only tell me in these 2 resistors, one is AD plus is the 19.5 volts, and here 2 resistors are given, R1 and R2. Here R2 is 49.9K and R1 is 324K. Now what will be the result here? See, the R1 is greater than R2. It means obviously here less voltage you will get. See, it's a 49.9. It's almost more than 5 times greater than this one R2. In that case, you will get very less, approximate 2.5 volts. Obviously, this one is for AC detect. Any charging IC, AC detect part will get 2.4 to 3.3 volts you will get. So according to that, this voltage divider will vary. Okay, now one more part we can see it here. See, what is that? R1 plus R2. See, R1 plus R2. See here, now R1 is 158K and R2 is 100K. Then what will be the output? See, power charge out is the source and destination is ground. So ground means it's negative. So in that case, voltage divider will happen here. So almost all charging IC, AC detect and AC OK part will have voltage divider. Okay, and sometimes ILM also voltage divider part will be there. And where you will get, wherever you get, the basic concept you need to understand. Okay, in case of two resistor, one is first one is connected to the source and second one is connected to the destination part is connected to the negative. Then only we'll consider as a voltage divider. Okay, any other places? Just I'm checking. So if you got that, so easily you can understand the voltage divider formula. How it looks. So that's it. It's very simple, right? Now you got an idea how voltage divider will happen. So please don't forget it. One more time I am telling you, R1 is greater than R2, then this part you will get very less volts. In case R1 is lesser than R2, then more voltage you will get compared to the source voltage. That's it. Today's class over. So in next class, in capacitor, voltage across capacitor and voltage across inductor, what it will be there. These passive components, how it works in schematic in laptop circuits. So slowly I am going, please cooperate with me because as per your knowledge, I am going very slow because all learner will be there. So for a fast learner, definitely I will move very fast in future. Please wait till that time. Okay, now basic is must. Foundation is very important. That's why I am going very slow. Thank you. Thank you very much. Welcome to Pavitra Laptop Care. See, today one important point I am going to discuss with you. See, now we have discussed already regarding the thing is main current. Means the flow of electrons. Right. Current is nothing but flow of electrons. Second one is to carry the electrons. To carry the electrons, what we required? We required voltage. Okay. Now voltage is a force, right? It's a force to carry the electrons. Carry the electrons. Okay. Where it will carry? In a circuit. Okay, these are very important point. One is current, second one is voltage, and third one is circuit. Okay, now circuit part came. Now what is the importance of circuit? Why circuit is required and why the wattage information? Power is a watt is equal to V into I. You know the formula of watt? So P is called nothing but watt. Okay. Now one important point which I told you, that is called adapter. Why adapter is very important to charge the battery? The voltage and current will decide through this adapter only. For example, this adapter capability will be 45 watt. Okay, but your motherboard capacity will be 65 watt. In that condition, what will happen? Instead of 65 watt in the nothing but voltage into current, right? Voltage into current. In case if you use 45 watt instead of 65 watt, what will happen? See, that's why I'm telling you, slowly why I'm coming is, see, the thing is current, voltage and circuit. These three, depends on these three only your laptop motherboard built. Okay, why these three are important. In adapter, you can see the current rating and wattage rating according to the circuit. according to the circuit. What is the combination of this one, and what is the relationship between these circuits with the voltage and current, that I am going to tell you. I will give you an example today. Okay, now I'll show you the voltage and current across the circuit, what difference will happen. The main thing is not only voltage, current should flow in particular circuit. Okay, so that one practically I'll show you in graphically I'll show you, then you come to know why these three are very, very important. Okay, see, in this circuit here I have taken an multimeter. This is multimeter, this is current amp meter. Okay, here is the battery and here is the resistor. Resistor value maybe 10 ohms for example I have taken. Okay, otherwise you can increase the value of this 100 ohms. See here, I increased the value of this resistor for see, this is 100 ohms. Now 100 ohms resistor has connected and here is the battery has connected. Battery is nothing but your adapter. Okay, now what is the value of this battery? See, in multimeter I am checking is the positive side and here is negative side. What is the voltage? Voltage is 9 volts. 9 volts battery I have taken. If you want, you can increase it. So what voltage you want? You want 20, right? So okay, 20 we will take. Now the voltage supply is 20 volts. Okay, 20 now. Usually all laptop will use 19 volts, 19.5 or 20 volts usually, generally. Okay, now what I am going to do is, see, here is the circuit. What circuit it is? It is open circuit. In open circuit, what will be the voltage and what will be the current? See, in the source, in the adapter you will get 20 volts, but this circuit is open, it's not connected to this source. Then what is the voltage? See, here is the positive side and here is the negative side. In the circuit there will be no voltage because it's an open circuit. Now current, here no, here also no. Okay, see, this is very, very important. Please keep it in your mind. It's very simple, but it's very important. Now what I am going to do is I will connect a wire here, positive side. So now also it's open. Then now what will be the voltage? See, still it's a 0 volts. There is no current at all. Okay, there is no current at all. So now what I am going to do is, now I will check from this node to this node. Then you will get it 20 volts. But what about voltage? What about current? Current will be 0 because it's an open circuit. If you keep the multimeter in negative part and positive part, definitely you will get the voltage. But in this part, this open circuit part, if you check, so there will be no voltage at present. Okay, now you come to know in open circuit there will be no current. Main part is we need current because the flow of electrons should be there. It means in open circuit there will be no current. This is the one point, major point. Now I'll connect the circuit. What will happen? That we will check. See this point. So I am going to connect this. What happened? Here current is 0.20 amps. 0.20 amps. See, all of a sudden if I open this, so it will be completely 0. Now what I am going to do is, see, in the circuit the electrons are flowing from negative to positive, but in conventional way it's positive to negative we are taking. Okay, see, the electrons flowing from here to here. Okay, now you got my point. In closed circuit only we can flow the electrons. This is the first point, and closed circuit only you will get the current. Nothing but flow of electrons, both are same. Now see the voltage remains constant in the circuit. Now one more thing I will do. I will take a resistor in parallel. Then what the difference will come? Now I will drag this one here. I will cut this part and I will drag this here. Now it's open, right? So now just a minute. So now I'll put one more resistor. Okay, just a minute. I'll drag this here. I'll cut a part here. I'm fixing a resistor here. Okay, now two series resistors are there. Then what are the changes will happen in series condition, that we will see. See, now I'm connecting this part to this part. Now circuit will get complete. Then the voltage is, total voltage is in the loop, it's 20 volts. Then what about the voltage here, this point? The current is reduced. See, current divided here. Current in series will be less. Current in series will be less. See, before what was there? It was 20 volts, because in series the resistivity of this resistor will increase, means it will add up. That is the reason current will be increased. So now what I am going to do is I will check the voltage. See, now the voltage is dropped because of this resistor and this resistor. The resistor got dropped because this value is 10 ohms. And here this value is 100 ohms. According to this ohms, the voltage will get drop. Now I will make it, I will make this resistor as 100 ohms. See, I will increase this 100 ohms. Just a minute. See, if I increase the value of this resistor, please check the voltage. Equally, it's reducing. See, 100 ohms I will put. What happened? Here 10 ohms. Total loop voltage is 20 volts, and the divided voltage is 10 volts. If I decrease this, the value of this will increase. See, if I decrease the value of first resistor, then the voltage drop across this will be more. Okay, see, if I increase this one 120 ohms, then voltage also will get drop. It means this one, if you consider as R2 and this one is R1, then R1, if R1 is greater than R2, then voltage across this point will be decrease. See, voltage is decrease. If I decrease the voltage, decrease the ohms in R1, say approximate 52 ohms, then voltage will increase. It means R1 is lesser than R2, then this point voltage will be increase. Okay, the voltage will be increased. Now R2 is greater than R1, automatically the voltage will increase. R2 is lesser than R1, then automatically this point voltage will be decreased. This is called voltage divider formula. Okay, voltage divider formula. If both are equal, equal resistor you will get, equal voltage you will get. See, equal ohms, 100 ohms, this one also 100 ohms, equal divided voltage you will get. See, current, what are the changes in current? In series resistor, the current is 0.10. Equally it will divide. Now what I am going to do is I will check here this node. See, everywhere the current will be same. Here, here, here. But the voltage, if you keep it here, it's a 20 volts, and here is the 10 volts. Okay, it means the current will be constant in series. Please note down, current will be constant in series resistance. In series resistance, current will be constant. The voltage will vary. The voltage will divide, but current will be constant. This is a compulsory. You must know this one, this formula. Okay. Now what I am going to do is I will connect it in parallel. Then what will be the result? See, here is the current. The ohms, first I will reduce the ohms of first this one. See what will be the current, total current. See, according to the resistance, current will increase. If it is less current, less resistance, current will be more. Resistance means what? It avoids the flow of currents. Okay, depends on your resistivity. Now what I am going to do is I will put it 100 ohms. See, 100 ohms I will put. Now I will make it as parallel. Okay, this point I will cut it, and this point also I will cut it. So I will fix this one to here and this one to here. Okay, now current is flowing here this side. Now what is the current? It's a 0.20. Now I will fix this one. Okay, see, here to here. Now what happened? All of a sudden current is increased here. The total current is the total current in a loop is 0.20 amps. But what about voltage? See, here is the negative part and positive part here, it's a total 20 volts, right, in the loop. But after this resistance, what will be the voltage? See, this point, the voltage across this point, just a minute. See, this is completely negative now, that's why it's not showing across this voltage. See, this resistor, these two resistor, these two are negative point and these two are positive points. If you check here, this is continuity, see, it's a negative terms. If you check here, this resistor, the voltage will be constant 20 volts, and in this resistor, what will be the voltage? Voltage will be 20 volts. It means what you come to understand is the voltage in parallel resistance will be the same, constant. Okay, in series it will vary, but in parallel it will be constant. The main point, in series it will vary, voltage will vary, but current will be constant. But in these conditions, in parallel condition, voltage will be constant. And what about current? See, current, the total current is 0.2 amps. Here also 0.2 amps. No. Before this it has 0.4 amps, and here 0.2 and here 0.2. Right, total is here, it's a 0.4 amps. Means once current will increase here, see, once current comes, in parallel resistors, before entering to this node, current will be more. Okay, then the divide will happen. No, in that case, equally the current will, equally means according to the resistance, equally current will divide. So what you come to know in this, the voltage across the parallel is constant, but current across the parallel resistance is vary. See, equally it's dividing. Understood my point? From here, from this node, before this node current will be more. Before it was 0.2 only, right? When you add the resistance, current increases to 0.4. See, this is the very important. This point I am going to tell you. Actually, I supposed to tell this one. The 0.4, before it was, when one resistor was there, that time it was 0.2. Now it increased to 0.4. The current capability from the source is increased, right? The current recognized, see, current requirement from the source is increased when the circuit is increased. This is one circuit and this one is circuit. See, in this circuit also current flowing and this circuit also current flowing. Means here two circuits made. For two circuits, the current requirement got doubled. Requirement will be more. In that case, see, in that case, the source should have that much of capability to deliver the electrons to the circuit. What the requirement to the required circuits depends on that, wattage will vary. Okay, now you got my point. In parallel, current will more at the beginning point, then it will divide as equally. So now I'll conclude this. See, the 45 watt, if you use 45 watt instead of 65 watt, the current requirement in the circuit, in case if it is a more than 45 watt, definitely your battery won't get charged. Okay, that is the reason the laptop should have, in case of 65 watt adapter only you have to put. In case of 95 watt only, 90 watt, in case of 90 watt adapter only you have to put, because battery won't get charged. To charge sufficiently, the input source also should be there. So now you got my point, right? The adapter current value should match with the circuit. Now you got my point. The circuit is very important because of this, the flow of electrons. So this is, please note down, it's very silly, but it's too complicated when you doing the service. Okay, that's it. Now current, flow of electrons, voltage, force to carry the, to pull the, push the electrons. Push, I'll put, that's the best option. Push the electrons. Circuit, in circuit, power wattage thing will happen. Watt is nothing but voltage into current. In adapter, in case of instead of 65 watt adapter, if you are using 45 watt, your battery won't charge because the current is depends on the circuit. If more current required, then more wattage you have to put in the circuit. In gaming and all, 180 watt or more than a 230 watt adapter you are using because of this. Okay, please note down. We'll come again with a new video with a new topic. Okay, very important topic. Now onwards I will start the circuits, means schematics. Thank you very much. Welcome to Pavitra Laptop Care. See, one more important point we will check in this video. The voltage across RLC circuit. R means resistor, L means inductor, and C means capacitor. Now for example, I have taken 1K resistor here, 1 millihenry and 1 microfarad capacitor. So if I give the 20 volts DC in these individually and combinedly, so what it reacts? Okay, these are positive components. Okay, keep it in your mind. The RLC circuits is a positive component. These are positive components. In positive components, the characteristics of voltage. Now what we are going to do is first we'll check the resistor. We'll connect a resistor to the circuit. It's an open circuit. What will be the voltage here and here? This is open. Keep it in your mind. The current won't be there in this. Only voltage will pass through the component, but the voltage difference between this and this will vary. That's why the voltage name will be V1 and here is the V2. In schematic, you can you already observed many times the voltage difference between this node and this node will be entirely different. Name will be changed. Even though it is a jumper, the name will be differ. Okay, you got my point? Okay. Now what I'm going to do is I will check the multimeter. See, this is a multimeter. In multimeter, what will be the voltage across this? Okay, one should be negative point. So now what is the voltage? See, 20 volts. So what is the input? It's a 20 volts. It means the resistor will allow the DC. Okay, it will detect some of the voltage, but by theoretically, if you see, the voltage will be same almost. So now what I'm going to do is I will check in inductor, means it will allow it or not. Okay, see, this point is open condition, this one is not connected. Now I'm going to disconnect this. Here also disconnecting. This one I'm going to connect. Which one? It's an inductor. See, in inductor, it's a 20 volts will be there here in this point, before this point, and after this coil, what will be the result? See, I'm going to connect this. Now I'll check for the voltage here. See, 20 volts. It means resistor will allow the DC and inductor also will allow the DC. What are the input voltage? Output will be there. But the one more important point is, what are the point B of this particular things? If it is connected to the ground 100%, that voltage will be ground only. Now the voltage is 20 volts. It means inductor is allowing the DC. Now we will check in capacitor. See, I'm going to delete this. I'm going to delete this. I will connect this to this, and this point should be 20 volts, right? So now I will connect this multimeter to this point, right? This is a positive and this is open circuit. Here we will check. So what is the voltage? Oh no, there is no voltage. Why? Okay, before this, what will be the voltage? Here before this point, the voltage is 20 because it's a before this point, right? So here, from here anywhere it can jump, right? But the thing is, it's not crossing this. Am I correct or not? Once again I will check. See, I will disconnect and I will connect this one. So now, just a minute. Now I will check once again. This is the positive point. here the voltage is no, very less voltage you are getting, right? So it means the thing is the DC voltage across resistor and across inductor will pass. It means resistor and inductor will allow the DC, but capacitor will oppose the DC. It means positively charged positive here and negatively charges will be negatively charged particle will be here only. Okay, it won't cross from here to here. You got my point? Okay, now what I'm going to do is this one I'll delete this. Now I will join all the things. All the things means here is the ground and here inductor to the capacitor, inductor to the resistor and resistor to the source. Okay, now what will be the voltage across here, here? See, first I will check before this point voltage is available or not. 20 volts. Okay, it's available. Now I will check in this point. So after this resistor, see the voltage is available. Okay, anyway, after this inductor, voltage is available, but here it's a negative is connected here, so that's why it will be ground. Now what I am going to do is capacitor I will move here and inductor I will move here. What will be the voltage across this point? This one I will delete. I will interchange this. This one also delete. See, this is a capacitor, inductor. Now I am connecting this point to this point, this point to this point, capacitor to inductor and inductor to ground. So now I am connecting this. I'll check this one before resistor. What will be the voltage? 20 volts. Okay, means it will allow the DC, right? So now I'll connect this here. What will be the result? Check the multimeter. Voltage is 20 volts. Okay, now I'll connect this part. See the voltage? No voltage. Why? This capacitor will oppose the DC. That's why you won't get voltage here. Okay, so now one more practical session we will do. Now I'll disconnect this. I'll connect beginning of this source. So what you will get? See, now I'll connect CRL circuit. Capacitor, resistor to inductor and capacitor to this. Now we will check here multimeter before this voltage, before this capacitor 20 volts, right? After this capacitor, what voltage you will get? See, after this capacitor, no voltage. Here and all, you won't get any voltage. See, here also I'll check. See, here, this point also, there is no voltage, 0 volts. Okay. As per this circuit, what we got, the information, the DC should not, DC won't allow through across the resistor, through the capacitor, not resistor, through the capacitor. The capacitor oppose the DC, won't allow the DC. It allows only AC signals, pulsated DC signals. Okay, the square wave and sinusoidal waves, what are the distortions are there, whole thing it will allow the capacitor. Here the resistor and inductor allow the DC but oppose the AC. So this is the main point. These two will be allowing the DC and opposes the AC, but capacitor is opposite to these two. Capacitor will allow the AC and oppose the DC. So you got my point. This is very, very important while doing the chip level services. Okay, now see, part by part explaining. I am explaining. Please note down one by one. Please make a note. Take a notebook and write down what I'm going to tell you. I'm repeating multiple times because of you should not forget it. Okay. Now what I'm going to do is I'll open a schematic and what are the combination of RC circuit, what will be the voltage, those things I will tell you. Not now, in next class. Thank you very much. Welcome to Pavitra Laptop Care. See, now we will discuss how your laptop will work. How laptop will work. How? The main thing is it will work through the current, the flow of electrons. The main thing is it will work through the flow of electrons. 1 minute. Time New Roman 3640. Okay. Now you got my point, right? How laptop will work. So for this we will discuss thoroughly. The main thing is it will work through the electronic component. What is that? The flow of electrons. The flow of electrons through the electronic components in a complete circuit. In complete circuits. Okay, like this your laptop will work. The flow of electrons through the electronic components in complete circuit. Here is the answer. Okay. Next question is, what are the electronic components are used in laptop motherboard? One is passive components, second one is active components. Okay, and the third one is connectors. Right, connectors should be there. It may be USB connectors or DC connector, DC jack or battery connectors. So many connectors are there. Okay, next, passive components, active components and connectors. What are the passive components? Next question, it will arise, right? What are the passive components? Number one, passive components. Which one? The one is resistor, second one is capacitor, third one is inductor. This is passive components. And next, active components. You have seen, right? What are the active components? One is diodes, second one is transistors, third one is, what is that? Diodes, transistors, MOSFETs, fourth one is IO, fifth one is chipset, PCH, processor. These are active components. Next category is crystal. It contains active as well as passive components. Crystals. Okay, using these components your motherboard will work. Okay, motherboard will work, right? So what are the main important in motherboard? Main thing is, first one is source, circuits. See, depending on this source and circuits, depending on these circuits the source is required. Okay, this one is important thing. Depending on this circuit, source will work. Source may be 45 watt or 65 watt or 90 watt or 120 watt or 180 watt. So depends on your circuit, the wattage will vary. You know the wattage in the sense watt is equal to current, voltage into current. Okay, this is very important point. So these circuits, what are those circuits? One is closed circuit, second one is open circuit, then one is short circuits. See, one by one chain link are there, right? So one is closed circuit, second one is open circuit, and third one is short circuit. Short means, you know, the jumpers. Open in the sense, one time voltage divider. For example, I'm telling, in between, after a resistor, you will connect it, but it will be complete circuit. But anyway, I will show you when we do the schematic things. Okay. Next, closed, always it should be closed. Source and destination. Source and destination. Destination should be closed. Okay. Then what else? Now you got right. So first one is source required and second one is destination required for complete circuit. Sometimes open circuit also will be there and short circuit also will be there. The laptop is combination of these three. Usually open you will see very rare cases. The close and short you will get it. The jumpers will be there, no? The jumper point, those are short we call, and it will short two circuits. Okay, next, that's it. Your laptop will work now. Now first point is the flow of electrons. Flow of electrons across a resistor. Resistors. So in series voltage is what? Vary. Current will be constant and resistor will be added. Okay, it means R total is equal to R1 plus R2 plus so on. Now you got my point, right? So in series resistors, the circuit in series resistor circuits, current will be constant, voltage will be vary, and resistors will be added. In that time, what will happen? The current will be very less. Okay, the total across the circuit, the current will be less. Next, in parallel, what will be the condition? The voltage constant, current what? Current vary, right? See, current will be constant in series and here current will be vary. Voltage will be constant here and there voltage will be vary. Resistor less. Okay, how? 1 divided by R total is equal to 1 by R1 plus 1 by R2 and so on. Okay, this is current flow of electrons across the resistors. The current limits through the resistor. In case of zero resistor, complete current will flow. In case of maximum resistor 1 mega like that, so maximum of current will reduce. Okay, what is sometimes it may be vary, it may be same according to the circuits. Now you got my point, right? So now resistor over. Now second positive components is capacitor. Okay, in capacitor, what are the facts? In series it allow AC current oppose DC. In practical I showed you in previous video. Okay, the main fact is this one. In source is a pin number 1, in pin number 1, and destination is connected to the ground. Then the voltage remains across pin 1. Okay, at the pin 2 it will be 0. In case of DC I am telling, this one is DC voltage. In case of AC voltage passes to ground. Okay, now in case of no ground, then in case of DC volts, both sides separate voltage will be there. Okay, one side will be voltage and other side, in case of separate voltage will be there, otherwise 0 voltage will be there. Okay, both the side pin number 1 and 2 will be separate one. Okay, capacitors over. In general instructions I am giving. Okay, capacitor over. Now diode, what it will do, one side, this side, anode side, voltage will pass. Cathode side voltage won't pass. Okay, it will pass in one direction, reverse direction it won't allow. That's it. Zener diode, so many types are there. Those things in separate video I'll tell you what are the conditions. Zener diode, in reverse it will work. Okay, how it will work, that also I'll show you. These are the main points. Transistors. Okay, in transistors, PNP. What is that? Base, emitter, collector. Okay, base no voltage, then it will be in on condition. It means from emitter to collector voltage will pass. In case voltage at base, it will be in off condition. It will be in off condition, means no voltage will pass from emitter to collector. Okay, this is in case of PNP transistor. NPN dead opposite. Okay, base, emitter, collector, 3 terminal will be there. In case of base voltage present, then it will be on condition. Okay, now what it will be there, from collector to emitter voltage will pass. If no voltage at base, then what will happen, no voltage will pass from collector to emitter. Okay, this is transistor NPN and PNP. Now what component will we use? These are active components. Okay, from diode onwards these are active components. Now P channel MOSFETs. See, in P channel what we will get? Drain, source, gate. Okay, this one drain to what? Drain to source, forward, see, in randomly I'm typing, it doesn't mean actually spelling mistakes and all. So what is in my mind, just I wanted to convey you. Drain to source, forward, source to drain, reverse. This is the indication actually. Okay, the voltage will pass from drain to source, but it will be blocks from source to drain. Okay, so now drain to source it will pass. That's called it's a P channel. If base, what is that? Gate has less voltage compared to source, then it will be in on position. Okay, in case more voltage than what is that? Source, then it will be off condition. Okay, when base voltage is lesser than source voltage, 5 volts, 3 volts like that compared to source. In case of source is 15 volts, 20 volts, then here gate voltage should be lesser than 20 volts, approximate 15, then it will be non condition. In case equal voltage or more than that, if it comes, the gate will accept, then what it will be the condition? It will be in off condition. Okay, like that. N channel MOSFET. What will happen? Here also drain to source, opposite, source to drain, forward. Okay, when base here is the gate. Okay, gate more than source, approximate plus 5 volts, then it will be on position. Okay, if less than source, it will be off condition. Means it's drain to source or source to drain, complete voltage will pass. Okay, complete voltage will pass. In case of it's a forward bias, right? Forward bias, when source to drain will be forward. When voltage given to source, then approximate complete voltage, approximate 0.7 voltage will drop here. Okay, because of internal diode characteristics. Otherwise, you will get complete voltage. Okay, this is the logic of active and positive components. Next, what else? Crystal. It produces frequencies. Produces frequencies means cycles, waveforms. It may be pulse or sinusoidals. That also I will tell you when the particular topic will come. It may be sine or pulse. This it will produce. Okay. Then what are the active components you will see in the motherboard? Or 3-leg, 6-leg MOSFETs, 3-leg transistors, 3-leg MOSFETs. And then see, in laptop motherboard, the MOSFET will work as switches. Even transistors also work as switches. It has a fast response. 3-leg switches and all. It has fast response. And crystals will produce sinusoidal. Okay. Now, one more important point I will tell you. DC will be in straight line. DC voltage will be straight line. Right. It won't carry any data. So, to carry the data, frequencies are used to carry the data. Data what I am talking to you, those are data. Okay, to communicate with one device to other device or one component to other component. What we are using? We are using frequencies. That's called SDA SCL. SDA SCL path for communication to carry the data. This also I will tell you in deeply. Okay, now we'll come to smart ICs. What are those? IO, PCH and processor. These are smart ICs. Why it's smart? These are active components. Okay, it's one pin is input. If it is a true, see all process are same. IO, processor and process. For example, a pin, the pin input is true, then what it will do? It will give appropriate output release. Otherwise, there is no output. In case of false, no output. Understand my point? No output. For example, sus, ash, SLP, S3, ash. See, ash is written for this only. If true, then it will pass. If not true, it won't pass. I mean, it won't pass. Understood my point? Very simple language I'm telling. Sus from IO and SLPS3 from PCH. Okay. Now, these IO, PCH and processor are connected with passive components. See, connecting through passive components, their characteristics will vary. Okay, their characteristics will vary. So what it does, it will check true or false. If false, it will be absent. If true, it will be present. That's it. So like this, your laptop will work. These are general instructions. If anything is left out, please inform me in comment box. So I will guide you all the things. So now we will start checking the schematic. Now the combination of circuit, how it will be there, that also I'll tell you. The circuits combination. How it's a positive components. Positive one kind. Okay, one possibility is positive components and positive components. Second possibility is positive active components. See, positive in the sense resistor to resistor, resistor to inductor, or resistor to capacitor. Second thing is resistor to IC. Here I'll note down resistor. For example, I'm giving to resistor. Here I'll take resistor as a example, resistor to IC. Okay. Third option is active in the sense transistors to MOSFET or MOSFET to transistor or diode to transistors, like that. Next, fourth option is active to passive. See how active in the sense IC to resistor or diode to inductor. Like this combination, the circuit will generate. Okay, IC to IC, or what are the active components are there? No, active to active. Here positive to positive, active to active, positive to active, and active to passive. These are the combination of circuits. So here it's very simple, but it's a complicated one. So I will show you in schematic what are the circuits and what the difference between those things. Okay, we'll see you in next class. Thank you very much. Welcome to Pavitra Laptop Care. The combination of circuits. So how the voltage will pass through a component or components. See, now the voltage may be 19 volts or 20 volts or 14 volts, battery volts, whatever it may be. The source, first is adapter source and second one is battery source. The source is nothing but a voltage. For what? To push the electrons. Don't forget it, to push the electrons in a circuit. In this circuit, what current you want, what electrons you want. Okay, how many electrons you want depends on that the voltage will carry. Now if you connect resistor, if you connect the second part is to negative, then it's a complete circuit. Complete circuits. Then this part, the voltage you can connect to some other circuits. Okay, maybe resistor or inductor or capacitors. Anywhere you can connect. So like that you can add up the multiple circuits. Again this one will connect to the ground. Then here is the circuit completed. Again this voltage you can take. But the thing is, concept is, here is the V1 and here is the V2 and here is the V3. That same thing it has taken, right? It's a V1. Then here is the V3, here is the V4 and here is the V5. And the V3 again it will connect to some other inductor or something. Here it's a V5 over V6. Like this voltage name will change. That's it. Voltage name will change, but here what component is connected and what you will get, that you have to observe. See, in case of this is not connected to the ground, if it is the open circuit, then here you will get 19 volts if you connected the 19 volts, and here also 19 volts, but some of the voltage will get dropped, depends on this resistance value, right? So here what you will get in V2, you will get 19 volts, and here it's the same voltage. Here this voltage has gone to here 19 volts, and here for example you may get it's 18 volts. Okay, just you think, and here some voltage will drop. Here it's approximate 19 volts. Again it will be 19 volts, and again it will boost, and again it's 19 volts. Here will be 0 volts. Okay, see the voltage difference, the difference between 2 point, the difference of the voltage happened. So here some voltage and here also 1 voltage. Even 0.0001 volts differ also, there is a voltage difference will be there. Then the name also will be differ from here to here. This is the concept you should not forget. So what are the circuits, how it will connect? As I told you, so a resistor may have voltage 3.3 or 19, whatever it may be. So here it may connected to the active components. The thing is, main thing is, if it is open, if it is not connected, then you will get 3.3 volts for sure, if this one is good condition. Okay, in case this one is connected here, the active components, the condition, internal logic condition, here the voltage will be there or not, this active components will decide. See, it will control the voltage or it will control the power. That's why it's called active components. Here the passive components won't control anything. Just it does its work. It won't changes anything. See here the active components, what it will decide. For example, just it's connected to AND gate. It's connected to AND gate. AND gate, what it does, it will compare two inputs. Okay, two inputs it will compare. This one is true, this one is true, then only this one will be true. Means this point will be 3.3 volts. If it is true, means it's a 1 in the sense it's a true only, not 1. 3.3 volts you will get. In case this input is 0, then the output will be 0. It means there will be no voltage or 0 volts. It means not ground. Okay, not ground, 0 volts. So this logic, using this logic, this voltage will work in a circuits. So okay, what are the ICs and what it does? See, for example, an active component, an IC I will take. IC. See, one kind of IC, it receives VCC. See, for sure it reduces the supply to activate. So now it's a on condition. So what it does, this characteristics is it reduces input and gives the output. Okay, what it reduces? It reduces 3.3 volts when it's on, then it gives the 3.3 volts. In case if it is the off condition, there is no VCC, it reduces 3.3 and here is the 0 volts because it's in off condition. This is one logic. Okay, other kind of IC, what it will do. Now again IC I will take. So obviously it reduces VCC source 100%, it should be there, then it will be in on condition. Then it reduces input. Okay, internally it asks a logic. Okay, the logic voltage will come. Here is the, that logic we call it as enable. If enable is true, means it's a 1 high, then the output will be high. Output will be 1 in the sense it's a 3.3 volts. In case input is the 3.3 volts, output will be 3.3 volts when it should be in on position and it should receive the enable signal. Now what will happen? Once enable comes, then the output you will get. In case enable won't come, if it is a false, then what will happen? Input remains here only. The output will be no result. Okay, the output will be no result. It means it's a 0 volts. There will be no volts. See, please keep it in your mind. These are very, very important points. So please note down. Once you get the input and once you get the enable signal, then only even VCC and enable, okay, then only the output you will get. Sometimes what will happen? You got one input, right? In some ICs, 2 inputs, 1 enable. Okay, input 1 enable, output is 1. Now some ICs, multiple inputs and 2 enables, multiple inputs and 2 outputs. Some ICs, more inputs and gives only 1 output. According to this enable, one more enable will come. This enable belongs to these inputs, this one belongs to this and this one belongs to this. See, first thing is this input should come and this first enable should match, then first output will come. Second thing is this enable should match, then second output will come. Third one is if these inputs are coming, then output will be here. Okay, this one is logic. So like this your laptop will work. It's very simple. Laptop, how it will work? The combination of logics. One thing you must know how electronic components will work. Depending on that, you will get the output result. Okay, see, now the PCH. Here is the IO. Here is the processor. All are ICs only. The PCH, for example, what I told here is the input. IO will receive the input. One is the enable signal. Then what it will give? It will give the output to PCH. When this enable comes and if it is true, then here is the output. For example, it receives 2 input and it gives the 1 output. Okay, again it receives multiple pin, it has no, for example 5 input it receives, then 1 more output it gives the PCH. Now PCH got 2 inputs, then what it will give? It gives the output to here or here. Okay, now processor, first thing is VCC should have, here also VCC, Here also VCC. It may be one or multiple. See, processor has multiple VCC, even IO has multiple VCC. You know the pin more than 5 or more than 10 volts it will receive. Even PCH also same thing. VCC. You know why it's multiple? Because here multiple circuits are there, multiple ICs will be there. One IC source, this IC source, this IC source internally. So like that, same. All IC. But the thing is, you must know what IO will do, what PCH will do, and what processor will do. Then it's very easy to do the laptop chip level service. You got my point? So sometimes 3 input, 1 enable. Then here the output it will give. I mean, what output it receives, means output from the IO and input to PCH. And if it is true, then appropriate output it will give. Okay, like this concept your laptop will work. Now I'll show you the schematic. It's very simple. Just I'll show you the schematic. Just you watch the schematic. How it's easy. The schematic is nothing but combination of circuits. Here I have taken 10th generation. 11th generation schematic. From beginning I'll come. See, this is a confidential, Campbell confidential GPT 52 MB schematic document LAK 201P. Here what I told, it's a processor, it's a SOC. What it connected? See, it's connected, I told only IO, so it's connected to ROM. One by one I'll show you. See, the input output, the games of input output, using that only it will work. First you must know what this IC and what it does. Okay, here is the RAM IC. What it gives? It gives 1.2 volts related voltages, reference or whatever it may be. RAM related voltage it receives and appropriate output it gives. Like that. Here NVIDIA graphic chips, it gives the output to this. Then it receives input and it gives the output, and it receives input and it gives the output to EDP connection. EDP only the output device. Okay, it receives the input from this processor and gives the display output. HDMI also same thing. Here LAN receives the input and gives the input to this SOC. Like that, multiple things are there. Here is the source IO. IO gives some signals through this 50 megahertz. Sometimes gives, sometimes won't, because of this 50 megahertz. Okay, so that in deep we will check. General instruction is that's it. So it receives the signals from other components, inputs, appropriate output it gives, and then you will get the display here. Okay, here only you can understand whole schematic. See what they are given. See this one in depth they have given the page number 23, 24, and here this SOC. This SOC also page number here it's not given. Okay, anyway. So for example, this one fingerprints 6.6, say 66 page number, and here 52 page number. This one completely depth they have given. That's it. Okay, now combination of circuits. So what is that combination of circuits? See here the processor. Processor, these are the output, and sometimes it's a bidirectional. In same directional only it receives the input and gives the output, receives the input and gives the output. That's called it's a bidirectional output. Bidirectional path. This is the output, this is input, this is the output, this is the output, this is the bidirectional, this is input. Okay, here the resistor, here 3 volts prime, the V1, V2, V3 what I explained, no, like that. This also 1 volt, but the name has given 3V prime. From where it has taken, you need to search it. Okay, so here it will come, and after that the same voltage will become the name as USB OC ash. Ash in the sense 100% it goes to IC, because I told you it's I2 components. I2 components in the sense here internal logic is false, then here it will be 0 volts, but practically 3.3 volts will be there, but internally that makes to ground, or internally it goes to 0. It drops the voltage, and in case the logic is true, then you will get voltage here. That's why ash has given. Now it's simple, right? Ash has given, it may be or may not be. Here directly what are the voltage will come, directly goes to the ground. The path, complete path, this also should be there. If it is open, 100% voltage will remains here and it won't work. The logic should be there. One time I will explain you how the IC logic will work. So now here also same thing. See the circuit. Here if any AC is there, then it goes to bypass the DC, and here it remains constant. Here see the same voltage 1.5 volts, here also you will get, and depends on the IC, the logic is there. Okay, hash in the sense logic is there. Here also hash logic is there. See, sometimes signal will carry through this path, but the thing is, for carry this particular signal will depend on this. If this voltage will come, then only through that voltage this signal will pass to other destination part. See, here it will pass through this voltage. If this voltage is not present, this signal will be present, but there will be no use. It's completely depending on this. That's why it's pull-up resistor has given. Pull-up resistors usually 1K or 10K will be there. Usually 2.2K or 1K, 10K. See, all signals and voltage will work through 2.1 volts, 1.8 volts, 1.05 volts, 3.3 volts and 5 volts. These are the major volts. It will travel, not 19 volts. 19 volts beginning only you will get. After that, using that inputs, outputs, then appropriate output you will get. Okay, see here pro chart. Same thing. It's very simple, right? Input output, that's it. Now somebody asked me in comment, YouTube subscriber only, it's a paid subscriber. See, DRAM RST, regarding the DRAM RST. See, DRAM RST, just now I told you it's a signal. Okay, the signal is depending on this voltage. If this voltage is present, then this one will carry. But the thing is, it will connect to the processor. This pin, page number 23 and 24, where it's connected, there you have to check. There the logic is true, then you will get the voltage. What voltage? 1.2 volts. Other than that, you won't get any other voltage. 1.2 voltage only you will get, because it's independent, not independent, it's depending on this voltage. So that's why you will get this voltage. In that voltage only the signal will pass. In case the logic is false in 23 page number or 24 page number, then this one will be 0. So I hope you got my answer. Okay, once again I'll repeat. This one is purely depending on this processor or where it has connected. The logic, the requirement is true, then only you will get this voltage, otherwise it will be false. Okay, step by step in deeply I will tell you in future classes. And this one is IC. See what it does. First VCC it required, from where it's a 1.2 volts. VCC, once VCC comes, it will be in active mode. What it does, here is the input, nothing is there, it's not connected. Here one more input, instead of enable it has connected here. But I see one source, if it is there, then destination should be ground. The path should be there. See, it's a ground is there, means it work will finish it here. So what work? It's input and output. The complete circuit will happen here. For what it receives input, it gives the output. For to give the output, the complete circuit will happen here. This is finish. This voltage we not required. The thing is, the concept only we required here. So that's why the circuit is completed. Now input came and output also came here. In case input is there, the appropriate internal logic is false, then output also will be false. It depends on this pull-up resistor. See, whenever the signals is dependent, then only you will get the pull-up voltage. If it is independent, then you won't get the pull-up voltage. Pull-up voltage is carried the signal. Here is the signal, so it's going to 86. In 86 page, it's connected to the processor or SOC, whatever it may be. So it depends on that 86 page. In case of IT components, it depends on that. The logic will vary. 0 or voltage will get. So now it's very easy, right? See, the same voltage 3.3 volts is coming here also, but the name is different. It's a V1 and V2. V2 name is SOC, this one, and here is a V1. So see, the ground in the sense 100% it's not a ground. Actually here voltage will be there, and the voltage what will come here, that one will go to here. It's a V1 will be present, but V2 will be absent because of ground. See, it's very simple. So reading the schematic, now it become very simple. Input output bidirectional, input output bidirectional, VCC input output bidirectional, VCC ground input output bidirectional. So this concept you have to keep it in your mind. Then you come to understand. See, input output, here VCC ground enable output, multiple enable 1, enable 2, output VCC ground. So using this logic only your laptop will work in active components. Okay, what are the logics? So step by step we can understand. So today that's it. So it's very important. We reached one stage. So now onwards you can easily understand the schematic. If you have any doubts, so please put it in comments. I will try to solve it. Thank you very much. Welcome to Pavitra Laptop Care. See, today we will discuss about voltage and signal. So what are the difference between these two? Now again we need to discuss about circuits. Okay, in laptop circuits, I will discuss only this one laptop related thing. Now see, in laptop motherboard, two kind of circuits will be there. Okay, one is purely digital, second one is analog, and both. Okay, digital or analog or both. Okay, see what is that digital and what is that analog and everything I will explain you. See, the electronic circuits. Before that, one important point I will tell you. Electronic circuits, some components will work only DC voltage. Some components will work only AC components. Why this differentiate is required in the motherboard? That is the main discussion today. See, now what we got: AC components and DC components. See, AC in the sense sinusoidal wave, and DC in the sense direct signal. I mean direct straight line. Now, why these two are required in the motherboard? See, what I am telling hello to you. See, hello. This is English language. Okay, this is English language. But this hello, you have to listen it. Listen. You have to listen. How you listen? This hello signal is a waveform. See, it will be like this, or it may be like this. H, it will take some milliseconds. He will take some milliseconds like this. Okay, these all are what we are talking. Those all are waveforms. Waveforms we will talk. See, the waveform has to be generated. Then only you can listen it. If I say hello, you can listen it. Those things through the speaker you can listen. Okay, this is called analog. To convert this direct DC to AC, something required, right? That's called circuits. Which kind of circuits? Digital to analog circuits. In some cases, what I am telling now, I am telling through the mic. So, mic. First, hello I told. Then it has to be converted as a digital. So, what has to be done? Here we have to use analog signal, analog components. What? Mic related. Those components will convert as a digital. So that's why we call it as a circuits, analog to digital. Understood my point? So what the circuit will convert analog to digital and digital to analog. Combination of these, only digital, only analog, analog to digital, digital to analog. Combination of these circuits is called your laptop motherboard. Understood my point? See, in analog signals, in digital signals, what are the difference in between these? That I am going to tell you. Now you understood, right? What are the circuits required? analog circuits, digital circuits, analog to digital converter, digital to analog converter. These are the main circuits in motherboard. Okay, now this one called pure analog sinusoidal wave. It's not good actually. So anyway, in simple manner I am writing. This is called analog circuits. Now some circuits will come like this. It will be straight actually. So while writing it will be mistake. See, this one is pulse. This one we call it as a pulse. This one digital analog signal. Digital analog signal. What is the digital analog signal? Is nothing but pulses. Why this one is required, that I am going to tell you now. This one also I will tell you now. This one is AC form. It may be like this or it may be like this. Then finally it will convert as a digital. Here pulse keep on moving. Why it's required? That also I will tell you. So now two kind of things we found: the signals in the waveform. This is AC waveform and pulse waveform. These two waveforms. Why these waveforms are required? But the laptop will take only 19 volts, right? Or 20 volts, whatever it may be. This one is straight line, right? Using this straight line, your circuits, what it will do? First, it will take in some circuits. Here is the circuits. It will convert as a waveform, and other circuit will convert as a waveform to digital. Okay, like this it will convert. First, what it will do? It will reduce 19 volts to this waveform. This I am talking about. This one, why it's required? This 19 volts is there now. In some circuit required only 3 volts or 5 volts or 1.05 volts or 1.8 volts or 1.5 volts. How we will get using this 19 volts? For this reason, these waveform circuits are required. Got my point? To convert this 19 to some other voltage, this pulse waveforms are required. See, this process I will tell you in next classes. Okay, generally you have to note down this 19 volts or 20 volts will convert to this voltage through the signals. How? I will tell you in simple manner. In general I will tell you. See, the main circuits, what I told, it's a passive components and active component circuits. Now here is the IC. See, this is very important. Please note down. This is the IC. What I told, IC required VCC. What volts? For example, 19.5 volts. So then what it will do? It will be active mode. Means it's on mode. Okay, this IC generally what it will do? It receives one input and other output. See, once it on, it receives voltage. Input it will take and output it will give. Okay, what kind of output? See, here input 19 volts it took and here it gives 3 volts. How? See, in these characters, in this IC, speciality is it receives 19 volts. Internally what it does, one more pin will be there. That one will be connected to MOSFETs. This MOSFET, how long it will be in on condition, how long it will be in off condition? This one here in negative mode and this one is positive mode. How long it will be on and how long this one will be on? Means off condition. This is low MOSFET and this one is high MOSFET. So 19 volts will come here, means here, right? 19 volts. Then here one signal will be there. This one is drain and here is the source. Usually N channel MOSFET in laptop as used. P also we can use, but in laptop as used N channel. Okay. Here something is ground. This is the gate. Here also gate. See what I am telling, it receives straight line. Then here the gate, using the gate for what? See, the MOSFET is nothing but through the gate voltage it will be on, means it will pass the voltage. If gate voltage is not there, then off. Right, this is the concept. So then what it will do, 19 volts came here, that time one MOSFET is on, so okay, then it's off. Okay, this time period it's a seconds, it's a time off, and again it's on, again till one time duration it will be on, and again off, again on, again off. See, this is a straight line is 19 volts. If this time delay it's off, then 19 will become as a 18, here 19 and little bit down it came, right? It means, see, straight line will become next here 19 converted as 18. Understood my point? Here is the off condition, this time delay is off, so that's why one time is minus 1, then 19 become as an 18 volts. Again some time delay, so again it's a 17, like that, step by step it will decrease the line. Finally this output here in between these two MOSFET, a converter will be there, that output will be in AC form. Finally through the coil you will get direct DC like this, 3 volts. Understood? See, it receives 19 volts on and off, then required voltage. So before doing the schematic, checking the schematic, these things has to be noted. That's why I am explaining important 1, 2, 3 like that. This is also very, very important one. So now the IC will reduce DC as well as AC. AC in the sense pulsated DC. We call it as pulsated DC to switch on the MOSFETs. Here 2 MOSFETs will be there now to on and off, to do the on and off. Okay, this is very, very important. So finally you will get in 1 point pure DC, 3 volts or 5 volts, whatever it may be. This is the concept for voltage conversion. So these all are called, it's a voltage. And what about signal? See, the voltage may be 19.5, 20, 3, 5, 1.05, 1.8, 1.5, 1.05 over 0.9, like that. The concept, a IC will convert using 2 MOSFETs. These 2 MOSFET may be external, or this IC is included. This IC is included, these 2 MOSFETs internally, and finally it gives the output. Okay, this one is pure DC. What are the things you are getting the output? This is a pure DC. How? Here it's a pulse. Here for gate it given the pulse. It means this IC is a smart IC. Now a word I used, it's a smart IC. All smart IC will generate pulse inside. For what? To switch on the or switch off the MOSFETs. So this is called smart IC. To do this smart work, what it required? Simply it won't do. See this IC, any IC, VCC came, here is the input it took, here is the output, but before this output, here signal it's required. It's called like enable. Maybe one more enable it required, enable 2, in case it has 2 output. Okay, maybe multiple. Okay, enable required, and then finally internally once enable comes, here pulse generator internally it has. What it means, it's a digital to input it to create, so digital to analog converter inside will be there. That one digital sinusoidal waves. Pulse is nothing but digital sinusoidal waves. It gives, using this it gives the output. Here it may be 3.3 volts or it may be 5 volts. In RAM section it may be 1.2 volts or 0.6 volts. Understood? Like this, multiple sections will convert voltage. Now the signal, again and again I am talking about only voltage. Now I will come to the signal. See, smart IC I told. Smart IC, VCC is required. Here is the smart IC. Okay, smart IC. What it works, how it works, so it receives a voltage. A voltage, it's a 3.3 volts. Okay, it receives one more signal, it's a 2.9 volts. Again, it will receive one more signal. Then, out of 3 signals are okay, then it gives one output. So, these are called, these are also voltage, but these are called signals. Communication signals. If these signals are come to this IC, then it gives the output. Output signal, this also signal. Why we call it as a signal? This also voltage, but we'll call it as a signal because in traffic lights, you know that yellow, red and what is that? Green. So in particular seconds it will be on and particular seconds it will be off and other one will start like that. So here a signal will come. Signal in the sense these 3 voltage comes, then it gives this output voltage. So these all are called communication signals. Understood my point? Here for example, here what is that? SDA ACL from the charger. Battery is connected. Here is the battery present. And here is the ID pin. For example, I am telling signal names. ID. You have seen in Dell. Without ID, it won't work. See, ID came here, and here SDA, SCL, battery present also it came here. Then finally, it gives a signal output to charging IC. To charge the battery. Here is the battery. Understood my point? Some IC will be very smart. It has multiple pins. Particular signals comes means nothing but voltage. Signals come, then it gives the output. Then a appropriate work has to be done here. Charge. What it does? Charge. Next, one more signal will come. For example, on, off signal. Then RSM, RST, hash, one signal will release here. Where it will go? It will goes to PCH. Okay, it goes to PCH. So like this, multiple input, multiple output. For example, 5 input, 1 output. That's it. PCH also, it receives this one as input and it gives 1 output. Otherwise, 3 output it gives. The main concept is now IC receives VCC, input, enable, output. In this concept, your PCH, IO, charging IC, RAM IC, what are the ICs are there, all will work in this concept. Okay, mainly 3 ICs are there. One is PCH, second one is processor. If both are inbuilt, we call it as a SOC. And here IO, here is the BIOS. See, using this BIOS, these all will work. What is that? Basic input output system. Basic input output system is a program. Okay, how this all will work? See, these all will work through communication signals. See how it will work in schematic. I'll show you how it will work. The first thing is, first we need to check the appropriate voltage. Second thing is appropriate signals. Then you will get the display. In this concept only your laptop will work. Okay. In schematic, I'll show you randomly what are the voltage and what are the signals. See here is a schematic. Okay, in this schematic, if you come down, here is the power state and PM table, power management table. See, what are the power management table? S5 to S0 state. See, one particular stage will be there. Delhi to Goa, Delhi to Bangalore, so many in between, so many states will be there. No, some stops will be there. So after crossing that stops only, you will get final destination. So like that. See, this is the source S5 state. Means you will give the 19 volts. No, after converting here, some voltages or signals you will get, and again some voltage signals, again some voltage signals. Finally, all signals you will get. Okay, so here power state will get the signals. See, SLPS3, SLPS4, SLPSA, always plan M, sus, run. Run is the final one. Finally, clock, processor clock will generate and you will get the display. See, S5 to S0 state. These are the signals depending on the status. See, in this state, these all are off, and this one is low, and here is high, on, and again, see, here always on. This one, when you plug the adapter, so all times, all stages, it will be on. Like that, these signals, here it will be low, in one stage it will be on. Here it will on like this, high, and again low, and high. Okay, so now here is S0 stage. See, S5 to S0 states. These are the voltage. See, in S5 state, these are the off condition. S5 AC condition, these are the voltage you will get at a time. What voltage? 5 volts, 3.3, always DSW. DSW is very important. Okay, PCH, RTC, 1.8, 5 volts, 3.3, 1.1 prime. Then next stage, see, these will be on. Along with this one, you are going forward, right? So along with this voltage will be on. 3.3, 1.2, 2.5. Again, after this stage, so actually previously it was S3 stage, now S0 IX has given. After this, these all are the voltage will be on. See, finally you require these all are the voltages, converted voltages, and these are the signals you want to turn the motherboard on. Now you understood, right? So what are the signals and what are the voltages? These are the voltages. How you will get? Using the smart ICs. See, generally I'll take that example of charger. One minute. See here, this is very important. I told you, hello signal. Hello signal, what are the ICs? Smart ICs will work. See, here is the battery. Here MEC is the IO IC. Here through this 2.2K and 2.2K, 3.3 volts always. Through this path, this is called SM clock and SM data. Through this communication channel, here 100 ohms also is the 2.2K resistor are there. Through this particular path, this one will talk to charger. See, charger IC and battery IC. So how? See, through this. This is the communication channel. See, it's a very important thing. If communication channel will break, then your battery won't charge or your laptop won't get on, because they have to talk to each other. Okay, these are called communication. Here it's a battery through PBAT, charger, SMB clock and SMB data. And here these are the communication channels. See, clock, SDA. Here we call it as a clock and DAT in case of battery and charger. And here SCL and DA as mentioned through the PCH communication. Okay, see here, so the same channel. Here what it communicates, it's a PD, WD, reflash, means bias. Here something is there. Here something is there, touchpad, and here DIMM. See, this is a RAM. RAM will communicate to the processor through this clock and data through this path. Okay, now you got right. So through the communication only it will talk to each other and it will produces the sinusoidal waves as per the requirement. Otherwise it will be straight line only. Straight line is goes to for VCC purpose to pass the signal. Okay, that's it, today's class. So in next class we will start the schematic. Always I'm telling we will start the schematic, but before that some important points has to be noted. No, that's why step by step I'm going to tell you. Thank you very much. We'll see you in next class. Welcome to Pavitra Laptop Care. See, now the actual schematic reading will begin. Schematic reading. Okay, how? See, the thing is, first point is 19.5 volts. How it will enter? Through the DC jack or adapter. And 14.5 volts, it's a battery volts, it will enter to the motherboard. Right, these two, what is that? This 19 and this one battery voltage will combine and it will give only one voltage. If it is greater than this, then 19.5 volts it will come. Okay, in case adapter disconnected, only battery is connected, then you will get 14.5. See, this is a 1 voltage. Where it will go? It will go multiple places. The multiple places, why it will go? It will go to divide the voltages. See, this one 19 or 14, whatever it may be. How it will work? See, here IC will be there. IC. Here first MOSFET, drain, and here second MOSFET. Here high MOSFET, here is the low MOSFET. Low always connected to the ground because it's a switching circuit. See, here it will connected. It's called phase. Okay, this is a common. Like this, 1, here 2, 3, 4, 5, and so on. The same. See, nothing will be changed. See, the same IC has middle one is the phase 1, and here it will be combined. Okay, 19.1 will convert as here it's a 3.3 volts, 5 volts, 1.05, 1.2, 1.8, so on. That's it. Your laptop finished. Means its reading is very easy. It's not complicated one. See, these are converted voltages. So main converted voltage. How it will come? The stages S5 stage to S0 stage. It means S5, S4, S3, S2 not there, 1 not there, directly it will come to S0 state. 1 voltage will generate in 1 stage. See, 1.2 will start on this. See, S3 stage. When this IC gets the enable signal, first it will give, it receives VCC. Okay, once VCC comes, then it will start on, right? So it will be in on condition. When enable comes, then it gives this procedure. The concept is very simple. Okay, you have to check thoroughly from important 1 to important this type. This topic, it's a 6 or 7. All you need to check. That's why I mentioned it is a very important. Okay, now I will open a schematic. How it looks like, that one we'll check. See, here is the schematic. And one more thing I'll tell you. These stages, why these stages are required? See, the main thing is here one IC, here one IC, here one IC. The voltages, the step down IC will generate now. It's a 3.3 or 5 or 1 point, whatever it may be. That will enter to this, or it may be this, or this may be this. To give the appropriate voltage, here is the buck converted sections will be there. The buck converted sections, which I told previously, those things will go to this particular ICs. This one will communicate with this. Maybe single, it gives only the output. It may receives the input from here, and vice versa. In some cases, bidirectional. Like this one directly goes to here and here also. Okay, in some signals, once it receives, then only it gives the output here, or output directly to this. Okay, this is the concept. By this concept only your laptop will work. To give the appropriate voltage to these particular main ICs, these buck converted sections appears in laptops. Okay, what are those? I will explain you. See, the laptop chip level service includes only these things. The schematic includes only these things. The thing is only the separate part will be there, no, that section which I see you are using, depending on that you will get the output. That's it. But main concept is high voltage you have to use and it will convert to low voltage. And here is the signal and voltages. It will move signal or voltages. These all are called signals. For example, RSM RST, DRAM RST, and SLP series. Those all are called voltages or signals. See, those things, it may be straight line or it may be pulse, it may be sinusoidal. Okay, anything. But the main concept is the ICs, these three ICs are more. 3 or more ICs will talk to each other. How? The communication path. The communication path. Using the communication path. What is that? Clock and data. CLK and data. Through this IC, it may be clock. It will talk to this. It requires some important data, right? So along with that clock, data also will move. Okay, it asks to this particular IC. Then what it will do? What it tells that it will do, it releases a signal. So it goes to here. So then it receives a signal. According to that, it receives an output. Again, it will ask. See, my task is over here. Next, what I have to do? Next, this IC will tell one more thing. Through this data and clock only, it will communicate. One task over. Second one, what I have to do? Next, it will give some other signals to do more task. Understood my point? So to do more task, and then again it will tell to some other part, and again it receives the output. Yeah, yes, I done what you tell, what you told. That information will come here again, clock and data. Using that clock and data signals, so it will talk to this IC. See, these voltage conversions are there, no, buck converters is nothing. The main thing is when it will talk, what signal it will release. After that, what signal it required. That is the main thing is here. Those points you have to understand. When, what appears, when the signal will release and what task it has to do. That's it. So these are signal games. Signal games. So that's why it's called smart ICs. What are those? PCH IO processor. Okay, it's very simple. PCH IO processor. See, in the schematic I'll tell you. Here is the block diagram. What I told, it's a CPU and PCH. Both are combined here. What it does? See here, one important thing I'll show you. This is the CPU. It connected to some other part. See, bidirectionally. But here, one thing you can see, it's a 32.768 kilohertz, 24 megahertz. These are pulse waves or sinusoidal waves. In some waves will convert as a digital pulse, in some are converting as a analog pulse to communicate with these components. See, through these analog signals required to talk to IC. What IC? Audio codec. In some cases, pulse required. how much speed it will get, that much of speed data it receives. The task, what I told you, the task it receives. See, bidirectional. Okay, this one is latest one, Intel KB Lake. Okay, Intel KB Lake. Here, what it does, through that signals, through these signals, kilohertz means it's a sinusoidal or pulse. Okay, through these signals, it will communicate with RAM section, and RAM, what it will do, what task it will give, that task it will do, and response it will give. That's it. For this, to make it active, the buck converted voltage required. What is that? In case of DDR4, it's 1.2. That's it. M.2, 5 volts required to activate this. Once 5 volts comes, this M.2 section will active and it will communicate with the CPU. Okay, next here, same SSD. What voltage? 5 volts. 5 volts. This one is 1.8 or 3.3. It depends on motherboard, it vary. See, the SPI flash, the main part is, this is the one. It's a very small one, but the big task it will do. 8 MB for KB Lake. The programming instructions, the smart chip, what I told you, the smart chip, the instructions, all instructions, this is the one will have. This one, SPI flash, the BIOS chip has the combination of instructions. See, this one will do some task, but before that, what it has to do, those instructions will come out from this. Once that task over, then second task, this one only will give. So these are programmed what we called pre-programmed instructions. It called BIOS. Dot bin. It will be in the, what is that? Dot bin, what we call extension. The program will be in dot bin or dot rom or some other extensions, whatever it may be, but the set of instructions is called nothing but programs. What programs it has to do, after what and what, after what and after what, finally what it has to give. The display, final display, till that final display, what are the sections, what task it has to do. All program has written in SPI flash. Okay, here IO, I told you, IO, it controls the keyboard, touchpad and some other functions it will do. There's some voltages, some signals it gives to SOC, PCH. See, I done already this work, so next what I have to do. So one output it will give. It will receive 3 or 4 inputs and finally it gives one output to PCH. Then PCH will tell once again you have to do some other things, next step. Then it will do some steps and again it will give. Some signals it directly gives to processor. Okay, finally. So the thing is, just you need to understand what signal is first and what signal is next. That is the main task here. Other than that, the schematic reading is completely easy. Need not to worry about that. It's not that much of tough. It's completely easy. See, this one I told you, I given a clue. See, all this, the main chips are IO, this one, and BIOS chip, and here NVIDIA chip. These are the main chip. These are sub chips, sub ICs. Okay, once you give the VCC, then according to the enable signal, the required signals are required voltages are required output it gives. That's it. See here, what are the voltage sections? The charger, okay, it's a 19 volts standard it will give. Next, that 19 volts will convert as 3.3, 5 volts is S5. The stages I told you, that one. Next, CPU core, see, CPU core, 19 volts it receives, 1 volts CPU core will get 19 volts. This one, see, it's power. CPU core power, 19 volts it receives, 1 volts VCCGT, and here CPU VCCGT, 19 volts it receives, 1 volts VCCGT. And next, see here, CPU VCCSA, 19 volts, 1 volts. Now you understood, no? Through that 19 volts only it will convert. It's a buck converters. Buck in the sense, it's a less voltage, low voltage compared to 19 volts. See here, 19 volts VCCSA, 19 volts 1D 1.0 means 1.0 volts. Here CPU 1.8 volts CPU required. DDR4 for RAM 19 volts we will convert as 1.2 and 0.6. See here in first page only you are able to see all the things. And in between switches that I told S5 to S0 state, the MOSFET will convert it will pass the same voltage drain to source or source to drain depending on the gate voltage. Those things here. Okay, that's it. The schematic reading is over. Now you understood, right? Now what I told, see, signals, the main signals, what signals you will get and what signal it will do, what is the input and what is the output. Okay, in next class the schematic I will explain you deeply what it contains and what are the tasks. Please note on, this is very important which I told you today. Okay, if you have any doubt please put it in comment. Thank you very much.